Hello to my Algebra 1s. Today we are going to be going over your multiple choice number 1 through 13 so you guys can have explanations and answers. So here we go. Number 1. Here is a function f of x and I ask you what is the value of f of 2. So what you're going to do is you're going to take that number 2 and you're going to plug it in. So it's going to look like this. 2 times 3. You put that number in for x. Boom. There it is. I, personally, would pick up a calculator and I would type that in. 2 times 3 squared plus 1. 19 is the right answer. Choice 2. Number 2. Now this one I have not taught you yet. This is a formula that you will have to memorize. It is not on your reference sheet and the formula looks like this. P. That's going to be your starting amount. Always parentheses, always the number 1, which represents 100%. After that, you are going to decide whether your 100% is growing or shrinking by a rate. That is going to be a percentage. That percentage must be written as a decimal. You're going to close it up, and you're going to study that for an exponent of time. Okay? This formula is important for you to know after Algebra 1. So now I'm going to plug in. In this, my starting amount, that was really weird, my starting amount is 64 players. So that goes in for the starting amount here. I told you, always the number 1 for 100%. Now in this particular situation, it's a tournament where we are eliminating half of the players. So I'm going to take away half is 50%. I have to write 50% as a decimal, okay? T is time, or how long are you going to be studying this for? And we want to study this for 3 rounds. So I'm going to put 3 there. Okay, now I've got all numbers. I'm going to go right to your calculator, and I'm going to type that in. 64 times 1 minus 50% for 3 rounds. And at the end of 3 rounds, you're going to be left with 8 players. Oh, shoot, I didn't even have to do this. Gosh, what is wrong with me? All I had to do is come up with this number. Answer, 64 is my starting amount. I am losing half of the players. Jeepers creepers. I should read the stinking question before I answer it. Well, there you go. Number 1. Number 3, here we go. Given this inequality right here, which number is not in the solution set? One thing you guys could do is you could take these numbers, you could plug them in for x, and you're looking for which one is not true or says false. But I'm going to do this one out. 7x plus 2 greater than or equal to 58. So here we go. If I solve this, take away 2, gone, greater than or equal to 58. 56, divide by 7, you get x is greater than or equal to 8. Well, here is the problem. A whole bunch of kids will come over here and they will select this. This is wrong. Which number is not in the solution set? Well, I've got numbers that are greater than or equal to 8. So if this was a number line, 8, 9, 10, it would look like this. 8 and above. So notice 7, 6. None of these have shading on them. The answers are bigger than or equal to 8. So which one is not in the solution set? 6 is not. All right, here we go. Number 4. Which table could represent a function? Every input has 1 output. Your trick, guys, we look at the x values only, and we want to find one that does not repeat. 1, 2, 3, ruh-roh, repeater, no good. Here we go. Take a look at the x's. 2, 0, uh-oh, right there. No good. Take a look at number 2. 1, 2, 3, 4. Hey, nobody repeated over here. There's your answer. And then this one, 2, 3, 4, 3 right there. Because of that number, that is not a function. So the answer is 2. All right, we are cooking with gas today. Taking a look at number 5. Which value of x makes this true? Guys, nobody wants to do this equation that has fractions in it. We could, okay? But what I would do is I would go right to my calculator. You could either take these 4 answers, plug them in, it'll say true, or you could use our little handy dandy menu 3, 1, and solve. So I'm going to end solve it really fast. X minus 3 over 4 plus 2/3 equals, disgusting, 17/12. Now remember, when we do end solve, after our equation, we're going to go comma, x equals 100. There you go. X is 6. I also taught you to do x is negative 100, but notice the answer either way is 6. There you have it. All right, number 6, which expression is equivalent to this? So what we're basically doing, guys, is we are looking to factor this. Schneider on your shoulder says look for a GCF first, and you can divide both of those by 2. So I'm going to show that when I divide by 2, 18x squared divided by 2 is 9x squared. Minus sign because of that guy. 50 divided by 2 is 25. All right, so that's my start. I always look for a GCF first. Then I look in here and say, oh, there's 2 terms with a minus sign. So my GCF comes down. And I'm going to do difference of squares. 9x squared is 3x times 3x. And 25 is 5 times 5. Now here's the deal with difference of squares. One of those is going to be a plus. One of those is going to be a minus. Answer, choice 3. There you have it. Okay, now this one I have crossed off. All right, I'm going to probably teach you that before school is over. Here is f of x. Here's the graph that matches with this equation. And then they say g of x is f of x plus k. So you take this graph and you add something to it. They want to know what the value of k could be. So I'm going to teach you super duper easy. If you take a look, notice all that happened is that went down 2. All right, if you take this point, notice it went down 2. You can take any point on the original parabola, 1, 2, drop it down, 2, any point. Let's go, look at this, boom, where if I go, 1, oh, look at, there it fell. So every single point on this f of x went down 2. So in order for this to go down 2, k is negative 2. Negative because we're going down, and 2 because that's how many boxes we counted. Okay, so this is something I have not taught you yet. This is actually a really, really easy thing to do, but it looks super fancy. So number 7, haven't taught you yet, but the answer is 4. All right, cooking. Here we go. This one, we're going to use a formula that is on your reference sheet. So we're looking at the shaded boxes here. So 2, 4, 6, 8, 10, 12. There are 12 shaded boxes in that first diagram. 2, 4, 6, 8, 10, 12, 14. There are 16 shaded boxes there. 8, 10, 12, 14, 16. There are 20 shaded boxes. So if you look at this pattern, it goes from 12 to 16, 16 to 20. It is increasing by 4. That is called a common difference. So we want to figure out how many shaded blocks would be in figure 35. They only went to figure 3. So if you really wanted to, you could keep adding 4 and then add 4 and then add 4 and continue until you got to the 35th diagram. But there's a much quicker and easier way to do that. And it involves this formula right here. It's called an arithmetic sequence. We're going to plug a number in for a sub 1. We're going to plug a number in for the common difference. And then this is the term we're looking for. Okay? So let me just jot that down really fast. It looks like this. A sub 1. It looks like that. So a sub 1 is the first number in the pattern. First pattern had 12 shaded images. This is what you are going up or down by. So I'm going up by 4. So I'm going to put a positive 4 there. Now, just for giggles, if I asked you to write that equation, you would take that and distribute it through. So it would be 12 plus 4n minus 4. Put that from 12, 11, 10, 9, 8. This would be a formula to help you find any number of boxes. How many would there be in the 100th figure, the 500th figure, whatever? So I want to figure out how many are in the 35th figure. So I'm going to take this, I'm going to put 35 there, and I'm going to figure out how many are in the 35th picture. So 4 times 35, oopies, not 350, that would be bad, plus 8. There will be 148 shaded squares. There it is. Okay, take a look at number 9, the zeros of the function. And another name for a zero is a root. It is where this graph hits the x-axis. So option number 1 would be to go to a graph and graph x to the third minus 9x squared. Okay, there's your graph. And you're looking for the zeros, which is where the graph hits the x-axis. Menu 5-1. Remember, if you hit the up arrow, it'll tell you. So there is a 0 at 0. And then if you needed to, you could, oh, jeepers. What is happening? Okay, 8. Let's take a look at 8. Nope, 9. Ooh, hit the up arrow, 0. So it hits at 0 and it hits at 9. Okay, how do you do it algebraically? You factor it. All right, there is a GCF here of x squared. Divide out x squared leaves me with x minus divide by x squared here, 9. So right here, and anytime you have a GCF that has a variable, there's where it hits, 0 and 9. Number 2. All right, number 10, crossed off. We have not done probability, nor probably will we. So here we go. Of the students who spent more time playing games on their tablets, approximately what percent are boys? So here we go. I'm looking at the people that spent more time playing games on their tablet. I'm looking at these people, right? So my question says, out of these people, the people that like to play games, what percent were boys? That's that. Okay, so if I'm calculating a percentage, I'm saying 138 were boys out of 192 people. All right, now that's not there. So what I'm going to do is I'm going to divide this. Whoa, 138 divided by 192. Pop a decimal point in there. What percent is that? Almost 72%. Here it is, 72. Okay, I think you guys could probably figure that one out. All right. We have just a couple more questions to do for this section, okay? Number 11, which statement best describes the solution of a two-variable equation? Two-variable, that means like x and y. Now, there's lots of things that could have x's and y's. Lines, that works, right? Think about a line. So which statement best describes the solution to a line? the ordered pairs must lie on the graphed equation. Remember when we did those lines, and if the point falls on it, you say it is a solution because it falls on the line. There's your answer. That is a weirdly worded question, but there it is. All right, taking a look at number 12. Again, another factoring question. Factoring is huge. This does not have a GCF. It is a trinomial. You would take x squared and break it into x and x, okay? Then we go to the back. We're looking for factors of 24 that add to be 10. Well, we can knock out 2 of these. 12 and 2 do not add to be 10. They add to be 14. Those are not the answers, okay? 6 and 4 add to be 10. So 6, 4. The signs are going to be the same. Oh, hey, same. Oh, can't knock anything out there. Signs are the same. What are the signs? Both minuses. Boom. There's your answer. All right. Which statement is true about the functions f of x and g of x? Now notice, g of x is this parabola right here, and f of x is an equation. Okay, it is going to be a U shape because of the x squared, and the negative leading coefficient means it's going to be frowny, right? So it's a sad parabola. All right, the minimum, the maximum, y-intercepts, roots, these two are equal when x is -4. Wow, I can't tell any of these things unless I actually know what the heck this guy looks like. So I'm going to go and I'm going to graph that control doc, right? That's what I want to do. There we go, add a graph. So here it is, -x squared minus 4x minus a 4. There's your parabola. Okay, it's a sad facey and it's over here. If you wanted, you could graph it on your other one. Okay, but let's just compare these. The minimum value of g of x. Well, the minimum is right here, -1, -2, -3, -4. So the minimum is -4. Is greater than the maximum. Okay, let's look at the maximum. Oh, the highest it hits on this axis right here is 0. Well, is -4 greater than 0? No. F of x and g of x have the same y-intercept. Well, here's the y-intercept, y-axis intercept. It hits at -4. Okay, let's take a look at this one. -1, -2, -3. Ooh, it looks like it. Let's just double check. Menu 5-1, let's trace it. What is going on? Menu 5-1. Y-intercept 0, -4. It hits at -4. This one hits at -4. They do have the same y-intercept. There's your answer. They don't have the same roots. This hits at -2 and +2. This only hits at -2. And they say that the graphs are the same at -4. Well, -1, 2, 3, 4. This graph is way the heck up here. And at -1, 2, 3, 4, this graph is way down there. So they're not going to be the same. So there you go. There's questions number 1 through 13 for the Algebra 1 Regents examination. Talk to y'all later.